the process in the process of accepting and processing credit card and non-credit card transactions. And so, when you click buy in your web page or mobile app and the charge is routed through Stripe, we don't have much time in order to run models that are predicting fraud and helping optimize conversion on behalf of our customers. And so we have many ML models that run in the couple hundred milliseconds that we give ourselves to process the charges on the Stripe side. Then the transaction is sent along to the credit card networks and the issuing banks. And so actually there's a lot that happens outside of Stripe's control. But in those couple hundred milliseconds, we are serving features, running ML models, making predictions, and kind of like routing the charge through a complex web of decisions. And that means we care a lot about latency, and so when we are shipping new models, we're running experiments that are trying to understand the impact of those models on latency, because it's not enough just to ship better performing models. They also have to be running quite quickly. So we pay a lot of attention there, and we pay a lot of attention to our ML serving and feature store and feature serving infrastructure. And I'm happy to talk more about that, but that's kind of been that infrastructure has been a game changer in terms of our ability to reason about latency, but also develop state-of-the-art models on top of it, while optimizing for performance and without taking too long to make the predictions.
In some moment, have you had to make the decision of making the trade-off, say, having a much better model in terms of performance, but sacrificing latency? I would like to know more about the discussion in terms of developing that. Okay, is this a real constraint or not? What happened?
Yeah, for sure, we can come up with all kinds of ideas that improve fraud detection, but take too long to run. And so there are conversations about okay, are we willing to take 10 extra milliseconds for this level of performance? What we found actually is that over time, we can make the feature serving and model serving aspects of our infrastructure faster in general. And so we've seen a lot of improvements on the infrastructure side that let us then test the crazy new ideas. But absolutely, we will gate production models on latency constraints, just as a hardware. We cannot go over this sort of P95 or P99.
And how was the experience of trying to fill out the infrastructure you need? You decided to start, okay, let's build from scratch, let's go to the market, see what we can find there.
Yeah. It was painful, actually. So when I got to Stripe, which was about 7 years ago, all our ML infrastructure was built in-house. And Stripe in general, we're sort of, because of the data that we're touching on behalf of our users, have a sort of conservative approach when it comes to using third-party tools, sending our data to third-party companies. And so when I got there, we had built everything in-house. It was very hard to use, very hard to optimize. And there were a handful of people at the company who could build new features to make them available for our models, and it just slowed down our development process by quite a bit. And over the past 2 or 3 years or so, we have migrated to a new feature store that is it's built on top of Airbnb's Chronos. For those familiar, we have our own sort of internal fork of it called that we co-developed with Airbnb called Shepherd. But that's just like changed the game really for the speed at which we're able to run experiments and ship new models. And lowered the bar in general for the number of people that can contribute to doing those things. And so that's been a huge difference.
Can you give us a particular example, let's say, of for a data scientist that in the previous stage you had to do a bunch of things. Now, how's the development process for building a new model?
Yeah, I would say that in the previous stage, data scientists would either have to pair with someone who was knowledgeable about this one system that we had built in-house in order to ship new features, and so that would be a months-long process. And today, data scientists can build new features into the tooling in days or weeks, and so it's really that like 10x style improvement that has just like helped us move forward so much faster. But more than that, it's just democratized the process because we're no longer bottlenecked on this one team to help us understand the intricacies of some system that we had built in-house. And so now the real win is that so many more people can
And what was the kind of features, let's say, in terms of the characteristic of the system that you selected that maybe other systems don't have?
Yeah, it's a good question. I sort of don't have at the tip of my fingers kind of like a full understanding of the whole market of systems that you might build into, but I think the capability that we really need is sort of consistency between online and offline features so that we can back test confidently and have the guarantees that the data we are seeing in our tests is going to be the same when we go online. And so that's whatever that's the main set of features that we need to deliver value and that have led to that sort of democratization.
You mentioned that the ability of running an experiment in global out. So I would like to know more about like whether you had to build or use another infrastructure for running an experiment, the type of experiments that you run, and Stripe. And the other question I have about the experiment is like, how is the culture of running experiment in the company?
That was a wide set of questions. At Stripe, we are running all kinds of experiments. I think on the infrastructure side, we have our own, again, we're sort of have a homegrown experimentation platform, which has pros and cons. The main pro side is we have complete control over everything that it does and can kind of like deeply integrate the randomization and the metric collection and reporting into our systems because they have to operate at low latency inside of the charge path in exactly the way we want. The cons then of course are like, well, there's a system that we have to build and maintain and make improvements on top of. So that can slow us down. Sometimes also at the infrastructure level. I'd say Stripe broadly, and this is sort of true of our ML models and our processes in general, we operate at sort of two different scales. First scale we're operating on is the high volume transaction level. And so we run a ton of experiments in the back end for payments processing where we're paying attention to conversion rates, auth rates, cost of executing payments, the latency and customer experiments are just more complicated to run because of the magnitude and or duration at which we have to run them to get signal. So we spend a lot of time thinking about how to design those experiments to get the feedback that we are looking for. And what was the last? Oh, yeah, right, culture. I would say those two different modes of operating then also feed into the culture of running experiments, because one of those modes, namely the transaction, high volume, fast signal, it's just so much easier to automate running experiments. So like everything we do is rolled out in an experimentation framework, and we can reason about the impact, and that happens relatively quickly. And then the culture, on the other hand, when it comes to the kind of like user experience, the sign-up flows, for those of you who use Stripe, like experiments within the Stripe dashboard or product experiments, that culture, I would say, because it's harder to run experiments, is not as, we don't have the same muscle around doing it, because we run them and then the error bars are wider than we would like them to be, and we end up making kind of not instinctual, but design-based or qualitative-based decisions in the end. In some cases, in the end, anyways. And so I think there has to be a balance there. Like, what are we really trying to learn? What are we really trying to measure? Are we doing it just because, like Matt said, we had to measure things, or are we doing it because we have like an actual user experience or trade-off that we're trying to balance?
Maybe a more fundamental question, like, how's the process of making the decision of running an experiment? Like, comes from data scientists by themselves, it's a or it's a team decision, it's across let's say, professional team that decides to run the experiment?
Yeah, I'd say that at the macro, like Stripe is a very analytical place. We have our leadership are very interested in measurement and communicating impact, and so that just makes it easier to talk about metrics and measurement and causal impact in general. So that kind of like baseline culture is floating through Stripe, which is great, and one of the reasons I quite like it there. Then in the micro, I think this question of, well, what are we really trying to learn? What trade-offs are we trying to perform is important. And that's where the kind of like devil meets the details. Like, can we actually give enough signal to understand the trade-offs? But to your question, we are working very closely between data science and product teams to answer that exact question. When do we need to run experiments? What are we trying to learn? And then after the fact, like, what happened? What did we learn? What is the decision moving forward? And we definitely have had cases where we decided not to ship things. We have to go fix X and Y about the product in order to move forward. And so there can be value, but we need to sort of be explicit on what it is we're trying to gain from experimentation in the first place.
Also, and related to that, like interaction between product and data science, how the company is organized in general, in terms of there's a kind of regular interaction, but each team do their things, or you create and sell, let's say cells, some things.
So Stripe is organized quite functionally. So we have a data science team, but we operate on what I refer to as a hybrid embedded model, where every data scientist on the team is partnered with a product team or an engineering group or a business team. And we're really like operating in close concert day in and day out with those teams. So we're going to their stand-ups and their planning sessions and their offsites and their happy hours, or just like whatever it is, we are sitting there with the teams.
You replaced it for a vendor, like even open source, right? How was that process for you, and did it help?
The process took a long time.
I can imagine.
But it did help because of this point that it kind of like lowered the bar to serve features and serve new model architectures attached to those features, and just kind of like democratized the process of who could contribute. And so now the engineering team who supports the feature serving, like just thinks about serving the features, doesn't think about developing the features. That's what the like domain experts are doing. That has just like sped us up quite a bit.
Do we have time for one more question?
Yeah, I want to ask if maybe I'm being naive, but I feel like it's different when you're thinking about experiments on fraud detection versus conversion. It has different implications. I think if you would, and we talk a lot about fraud detection, like what are the nuances there about designing an experiment around fraud detection and the trade-offs of running an experiment and risking maybe increasing fraud for the users or something like that?
Yeah, for sure. So there are two aspects that make fraud detection in the payment space problematic. The first is that we actually don't get signal on how much fraud increase or decrease is coming in often for weeks after we start the experiment, just because I don't know if you've ever been the target of credit card fraud, but you see it on your credit card statement a few weeks later, then you call the credit card company, it kicks off this like long asynchronous